Hey guys, and welcome back to part 2 of our video on designing a bolt and nut. I'm Rob and I'm going to be taking you through these next couple of steps of Fusion 360 today on the Design to Manufacture channel. Alright, to get started, just a recap, we've quickly made a bolt and a nut. We're running an M10 thread. They're not the prettiest things in the world, but I'm going to be showing you guys how to do a couple of key functions now that we have our bolt and our nut. We are going to go through how to make an assembly, specifically a cylindrical assembly in this circumstance. We're going to go through limit setting in our joints. We're also going to go through motion linking, and then we're going to go through rendering our image so it looks somewhat realistic inside the Fusion 360 program. So I hope that sounds interesting to everybody. I'm going to get stuck into it now. So straight up on this one, we're going to spin our object around to make it easier for me to grab the parts that I need to grab. And then we're going to go to our assemble menu, and you can see the joint button here. So we're going to use that. We're going to go to our nut first, and you'll notice that I can't grab the center of the nut at the moment. I can only grab anywhere there's a face. Alright, there is a trick to getting that center of the circle, and that is holding in control on my keyboard. I'm able to select that center point now for my joint. These are little targets basically that tell me where my joint is going to go. So I want this little target here to line up with this little target here on the bottom of the bolt. And whatever object you click first will be the one that moves. That's a nice hint to have. Object 1 will always be the one that moves to object 2, which is why I selected my nut instead of my bolt. I'm just going to swing back up to a home view so you guys can see what I've got. And we can see we have a bolt here. In my motion, I'm already on a cylindrical and I'm running Z-axis. If you've got a motion that goes in another direction, you can change the axis there. Or you can even put in a custom axis if you can define it. Alright, I can change some alignments and some offsets, so I'm going to drag it up a little bit. Alright, and then what I'm going to do is I'm going to turn our analysis back on. For those of you that remember, the analysis creates a little cross section, and I'm going to try and line this up so it is in line with the thread. So I'm just going to flick around to the right view, grab my pan button, move to where I need it to be, and I can see I'm not quite there. I think I'm going to go a little bit less than this. I'm going to go -10, too much, 0.5, a little bit more, 0.6. Alright, that's pretty close, but see how there's still a bit of a gap on the underside more than the top? Alright, so I'm going to go a little bit further. I'm going to go 0.364. That's probably a little bit too far. I'm going to go down 1. There we go. So that's given us relatively central gap. While I'm here and I'm showing you guys the inside of the teeth for the bolt, if you guys are going to 3D print bolts and nuts, it is worth jumping in your bolt and nut, or probably just the nut in this case, and just extruding those lines or the faces of the thread back in a little bit to make the tolerance a little bit larger. You want at least a 0.2 millimeter, if not a 0.4 millimeter tolerance on most plastics, depending on the quality of print, the time you're taking, and all of those other things. So just bear that in mind if you are printing something like this. But that's good for me, and I'm happy with that, and I'm not going to go into setting the limits in this screen. I'm going to show you how to do it once you've made a joint. So I have a joint now, alright, and it is there. I can see that it exists. Can't really do anything with it at the moment. That's okay, but we're going to go over here. So in my relationships menu, I can see joints, and then I can see cylindrical here. I'm going to right click on it, and I'm going to go edit motion limits. Alright. So what that does, so if I have a look at my limits at the moment, this is doing the cylindrical one. I don't want any limits on this. I want it to be able to spin freely, so I don't have to do any motion limits for the cylindrical. If you wanted it to only rotate a certain amount, you can change the minimum and maximum values here. All right, but I'm happy with that. So I'm going to look at my slide mechanism. I want to set a, pardon me, I want to set a minimum and a maximum value. So my minimum value and my maximum value, minimum is going to be going up. Let's go negative 40. Yep, that goes in the up direction. All right. So I can see that's going up a little bit too far at the moment. I'm smacking into the head of my bolt. Let's try 39. Perfect. And now if I have a look at that too, that motion limit has stopped perfectly where that thread's aligned. So I'm absolutely chuffed with that. I'm going to call that my upper limit. So that's done. And my lower limit, or my maximum in this case, will be, oh, sorry, I didn't mean to change my view there. I'm going to pan down. If I go 0, right, and preview that, we'll see it goes, oh. So it's coming back down to where it was stopped. All right, so I'm happy with that limit. So that's how we do a motion limit. You can set all of these things up on your own joints depending on what you need. And that's great. So now I hit OK. And I'm going to spin around. Home it up. And I'm really happy with that joint. But if we animate that joint, can we see that the thread, as it's animating, it's just not lined up perfect? And this is where we need to set a relationship between our rotations to our movement. So I'm going to quickly turn that off. All right. And I'm going to set up this relationship now, or link. So we go assemble, and we can go motion linking. Click the joint that we want to do, all right, and link with the same joint. So now, this is a little bit of information for you guys. All right, oh, it's already in there. Your bolt will travel whatever the pitch of the thread was. So if you remember, this was an M10 by 1.5 thread. So that means the gap between these 2 points here is 1.5 millimeters. That means your bolt will travel that distance every 360-degree rotation. So with that value here, you can see that as it comes up and down, it maintains that lovely equidistant distance from our thread. And that's a really nice, realistic way of demonstrating how a bolt is going to move up and down. All right, and I'm just, for argument's sake, I'm going to show you it at 1.8. So you can see the difference. You can see that that's just not keeping in touch with that thread. All right, so we are definitely going to go for 1.5 and hit OK. Why do we really want this? While it doesn't serve a huge purpose in our 3D modeling, it can make a large amount of difference in realism if you're modeling up how something's going to work for somebody. Obviously, everyone knows how a bolt and nut works, but if you're making a mechanism that you're trying to explain to somebody, if you can set up your joint so it is realistic, that's something that's going to make your point a lot easier to bring across, and it's going to make whatever your consumer is a lot happier. And you can see I can manually manipulate that, and as I'm spinning it, it's moving up, right? And I can go in the other direction and go down. Right. But that's how we do the thread. That's how we set our animations, and that's how we assemble it. All right, so now that's done. we're going to show you guys how to put a rendered finish onto your job. So there's two ways to do this. The first way, you can go into the design menu and go to the render section, and that will drop you in a lovely sandbox, and it will give you some texture for what you've got. All right, and then you can simply change the appearance of your items up here. All right, that's a nice easy way. All right, but you can actually access that appearance section in your menu here in the modify. You can just go straight for appearance, and it will give you the same drop down box. So you can select to do on faces or on bodies or components. And then there should be a Fusion library here of materials. So you can see it has a whole heap of different materials. I'm just going to go for metallic, and I'm going to grab this one, the anodized glossy blue. And I'm going to drag it in for the bolt, and that makes that nice anodized blue. And just to keep with the theme, I'm just going to grab this bead blasted aluminium for the nut. Alright, I'm just picking these at random, guys. Some of them are better than others. You can see that one is pretty bland. Alright, but let's grab that glossy grey. Alright, that looks a little bit tidier. And that just gives our object a bit of realism, a nice way to differentiate between points or surface finish or any of those things that you'd like to do. And as you can see, there's a ton of different options. So again, I can grab different materials. Alright, so gold, alright, or even something like concrete. So if you're designing something that may not be a bolt or a nut, you can put pretty much any finish onto it. So let's go metallic black. Usually you'll have to hit the download button to use the render and to make it save properly. Alright, that's just a little trick. Once it's downloaded, you can just flick between them now. So I can just go for the same anodized finish and drop the satin in there, or the anodized black. You can just play around. Get something that's you're happy with is usually the key. Alright, and once you're happy with that appearance, you can just close that menu up. And we are all done for today. That marks the end of the part 2 video. I hope you guys learned something out of this. There was a lot of really cool tips and tricks in there. If you want me to look at any of those in more detail, please drop a comment, hit like, hit subscribe, let me know. That way we can keep this channel going and you can get the content that you guys want. So that way everyone is happy. But until next time, I look forward to seeing you all in the next video. Alright, see yous.